Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're gonna talk about SanDisk Pro Blade ecosystem. So let's dive deep into it. So what exactly is the problem right now? Well, problem is that high resolution photo and video are becoming commonplace. So we are reaching a point where media again is becoming a weak link. If you are old enough, you must have remembered there was a time where digital camera was to store data on floppy disks. There is a lot of movies that's like, camera, floppy disk, why? Because again, that time flash memory was not good enough. So we are very 90s to let's say 2005, I would say we were in a scenario where digital technology was very advanced. It's just that data storage was not good enough. But with the advent of SD standard and development in flash chips, this slowly started to took over everything, and this became the de facto standard. However, because this finally matured enough, we created a scenario like, what if camera had more resolution? Basically, back in the old days of 2000, you could barely get like 12 megapixel of full frame digital camera. Right now we are exceeding 60 megapixel, and some of the pixel shift technology allows you to go up to 200 mega freaking pixel. So photos alone, and these photos are raw photos, so each photo could easily be more than 100 megabytes. So we are reaching a bonkers point where the data of just photos itself, and not to mention some cameras are a bit emotional with shutter speed. They are reaching 120 shots per second. So yeah, we are getting carried away, and even in stills only we require a very bonkers throughput to clear buffer. Otherwise, your camera will bog down. And video, let's not even talk about it, because most people do not understand that, because most people's average exposure to video is from YouTube's, from your mobile phone. Problem is these are compressed format, and they are compressed in brutal way. Basically each frame is compressed, and then multiple frames in between is missing, it's not there. So you have frame A, keyframe it's called, you have keyframe, and then you have frame number 1, frame number 2, frame number 3, frame number 4. 4 is the keyframe, and these between, poof, there is just mathematical data what should be there. So fundamentally this is a really bad format for editing and working, and it's very compressed, but this is very space efficient, and most people cannot tell the difference. So you can just use it for YouTube, Netflix and all that. But once you actually have that all frame data, yeah, it's bonkers. Like even my Canon 800D, which is only HD, only 30 frames per second I'm recording, but because it's just storing every single frame, even though frame is compressed, the file sizes are bonkers. Like even 30-minute recording easily crosses 6 gigabytes. Like you can do 8K at mobile from mobile phone at that kind of capacity, simply because again each frame is not being stored. So we video storing every frame is very expensive. On top of that, now do raw video recording, yeah, that's reaches a point where it's like you need a server to store it. So we reached a point where media became a weak link. Now we did try to upgrade the SD. Now if you're old enough, you must have seen, like I went through this. SD basically went from your back in the days, camera used to say how many gigabytes it can support. So very old cameras, 4 gigabyte. Whoa. Then SD HC was created. That was an upgraded protocol standard, so it can directly document larger gigabytes. Basically it has to index it, right, where the heck the data is. So that indexing general, so to say, was not designed enough to handle more data. So then SD HC was created. That was like, I got you fam, 32 gigabyte. My Zoom H1N recorder can only support 32 gigabytes of micro SD card. It cannot support larger, even though we can buy it, but that goes to SD XC. XC can go up to, I think, very high, 2 terabytes of capacity. So we have been upgrading this puppy, but we reached a point where this was just not okay. Capacity went up, no problem, but the throughput, basically how fat the pipe is, that was not fast enough. So we added these extra contacts, but this created a problem. Like this does work. It's like this puppy can barely touch 100 megabytes per second. This can easily touch 300. Like 250 is like just shut up, take money. So I'm using that in my camera, not because the camera can use it. Camera is still UHS 1 only, but my card reader is UHS 2. So idea is then when I'm dumping the footage from camera to computer, that step is like much quicker because I'm utilizing this. So because of the backwards compatibility, and because of the fact that you are adding system and the protocol itself is not that great, it reached a ceiling. Meaning now there are push for making third gen technology of it. It's like most people are like, yeah, not worth it. There is a talks about it, UHS Mark III, but people are not interested into it. It's like, it's just not worth it. So this reached its upper limit. So what can we do? Well, we went back to the drawing board and looked at the most successful thing, that is Flash storage went from like $625 per terabyte in 2013 to right now 2024, 35 terabytes per $35 per terabyte. And hard drive, even though it started a very generous like leadway, $36 per terabyte, which again the gap is huge, but you can notice just from 2013 to 2023 the gap has like shrunk a lot. So now it's barely like 3 times more, but here it was like multiple times more. Again, it's logarithmic, it had to be, otherwise it will not fit in the same graph. So flash chip, basically this black box that you see that has to store all the data, that has been manufactured in millions of units per day. Like we are mass producing this like they are going out of style. They are used in laptops, they are used in NVMe, they are used everywhere. So due to competition, mass production, the price of these puppies per terabyte and per megabits of speed is very low nowadays, like free low kind of, meaning UHS 2 card slot versus this puppy, they are the same price, but this would be multiple times more fast. So price is coming down. So what can we expect? Well, this should have allowed new formats to be created. That was done. First XQD was created. XQD was not selling very well, so Sony and Compact Flash Association, they got in bed together, they made a new baby. That baby is basically CFast Express. Now you're like, hey, it looks exactly the same. They are the same thing. They are pin compatible. As long as you have the firmware, your camera, most old cameras that have XQD, they have gotten a firmware update where you can just like, okay, I'm gonna put a CFast Express card on it. It will work. Again, this was NVMe, this is NVMe. Now, what is NVMe? NVMe is a protocol that utilizes the pipeline of PCI Express. So PCI Express is the pipeline, NVMe is the protocol, is the water that flows in the pipeline. And benefit is it's bonkersly fast. This fundamentally was designed in 1990. So no matter how much upgrading you do, inherently is not that good. Now, CFast cards were invented. That was basically SATA cards. Like you remember compact flash cards, they were PETA cards. If you were old enough, before SATA, we used to have like a lot of parallel interface. So PETA got upgraded to SATA. It did not sell that well. That's why they got into bed with Sony, because again, Sony had a format, XQD did not sell well. Compact flash had a upgraded format that did not sell well. So the both of them made money together, and voila, we got Express. This is selling well. So this is basically NVMe protocol over PCI. Benefit of PCI is that you no longer need to increase the pin count. Once you have the pin count, let's say these two are Gen 2, same hardware, same slot, same physical drive. If you can just keep changing the circuitry, you can keep increasing the speed and double speed. Basically, you can go from, oh, right now it's doing 700 megabytes, right? You can easily go to 1400. You can even cross 2000. Why? Same as this. This started to appear in the market when PCI 3.0 was the standard. So it was limited by PCI 3.0. Technology improved and all that. Same hardware, M.2, NVMe protocol, same hardware, just changing the basically electronics inside it. Voila, this can go up to now PCI 4.0. And if you have money, PCI 5.0. That is ludicrously fast. So that's why we are now switching from SD algorithms to NVMe. So when you see type A simply means single lane. Type B means dual lane. There is type C that's supposed to be quad lane, that's made for video cameras. I have not seen it yet. So these supposed to solve our problem, where it's like we need a lot of data and we need really high speed data. Did they? Not really. And ironically, CFast type B is so big, physically so big, you can buy a, like this length is the full length NVMe. You can buy a smaller one, put it inside there. Yes, it's pin compatible. They just basically have a physical pin. You can do it, like you can buy it. Not recommended though, but again, if you are like fed up with the ludicrously high prices of these, you can do it. And why the price is so high? Well, there is a lack of competition, because now camera companies are stuck. Do we support this? Do we support this? Or do we support XQD? Do we support Sony's weed? I'm old enough where I remember Sony was hated this part. They were like, this weed is not strong enough. Let me make our own weed. We call it Sony Magic Gate. I'm not joking. That's the name. Sony Magic Gate. And yes, I have used smartphones that had that format, Magic Gate. Heck, if you open A7 Mark III, original A7 Mark III, it has Magic Gate stamped on it. They were like, people will buy it. Nobody bought it. Nobody bought it. And again, same thing again. I'm like, dude, you made this. You made this. You solved the problem. Problem solved. Just use this format. But they're like, but what if we not create the e-waste? How will the world die? I mean, like, we have to make sure we create more e-waste. So this e-waste. So now people have too many choices. You have UHS2 choice, you have CFast Type A choice, and you have CFast Type B. Thankfully, more and more companies are going in Type B, so that price is coming down. But you see, there is too much conflict. 3 active models right now, and because of the low competition, because of adoption rate, poor adoption rate, we are stuck. So neither the cost is good, neither the availability. Meaning right now, even though we should have reached a point where 2 terabytes, 4 terabytes should be easy, be mindful. This puppy is rated for 2 terabytes. You can't buy it yet. This should have started with the 4 terabytes. You can't buy it. So availability is low. Even if you have bonkers amount of money, you can't buy it, and cost is stupid enough. So basically, we were hoping that SSD would save us all. It did not. So that's the problem. Even though SSD's price went down, it did not save us. So a big company known as SanDisk, which was sold to Western Digital, they're like, what if we created a new ecosystem to solve the problem, specifically with video people? Because while photos are getting heavy and burst rates are going up, they're still manageable. Meaning, practically speaking, UHS2 is like, I got this. I'm pushing it, but I got this. Me good, me good, me good. And you're not supposed to go with Sony A7 A9 Mark III. You're like, that's not you're supposed to. You're shooting a movie at that point in time. So in terms of raw video recording, they require ludicrously high bitrate. This cannot do. Even CFast, you can buy it. It has the speed, because again, NVMe protocol, it has the speed. Problem is, it's just very small capacity. You will buy 256 gigabyte, it is expensive, and you put in your camera will be like, yeah, at raw recording 9 minutes. I'm not even joking. Not even joking. That's how little you're gonna get. So they realize there is a hunger in the market for something that is actually cost effective and huge. So they created, okay, I specified that NVMe is a data protocol that flows in the pipe of PCI. So PCI is not designed for external communication. However, USB is. USB-C is an awesome system. So they're like, hey, what if we take the NVMe protocol, convert it into USB, and used USB for everything? So that's the core essence of it. You take NVMe SSD. This is just a pin adapter. Basically, this is upgraded version of how Red Camera company used to F the customer. This is M.2. There is a different version of same M.2, but instead of NVMe, it's SATA. So it only goes up to 600 megabytes per second. It cannot exceed that. That's the interface limit. While this puppy can easily cross up, depending on PCI generation, it can easily reach 3000 megabytes per second, basically 3 Gbps. So it's just a pin adapter. Now, why do you need pin adapter rather than directly using this kuchung kuchung? Two problems. First, these are not designed for hot swapping, meaning if you pull it out while it has electricity, it will sort out. The basically ground plane should be the last one to be disconnected. Like there has to be certain handshake. Like your USB plug has designed for that. It's designed for hot swapping. This is not. So they're like, what if we put a bridge, so to say? That bridge is designed for taking that hot swapping load. It's like, that's why it has some capacitor to like, whoa, to basically making the marriage and divorce very easy. So that's all it is. It's just a chassis, and you put NVMe and you get a bridge. Now, why do you need to use this? Well, NVMe, while they are awesome, they are heavy, as in intensively, computationally, they are very heavy compute. That's how you get that sort of stupid speed. Consequence, the SoC, there are two parts to it. First, you have NAND flash, basically this sort of black chips, and then you have controller chip. Controller chip gets hot, like ludicrously hot. So you need to dump that much heat. Now be mindful, the heat amount is not much. It's barely 1 watt to 5 watts. Problem is, it's concentrated too much. It's almost like how you have 60 watt soldering iron that reaches 400 degrees Celsius, and you have 1600 watt heating iron that is for close that barely reaches 150 degrees Celsius. Same thing. Is a heat is not much. Like the energy is very little. It's just that concentrated too much. So this whole chassis does two functions. First, it gives a physical place where you can hold it. Second, it's a very good heat sink. And this is a very big issue with CFast cards. That's why when RE was making their new upgrades, they were like, yeah, we will not use CFast, we'll use our proprietary. The reason was CFast does not perform very good if it starts to heat up. And again, pay attention to all Canon cameras, Nikon cameras. You open the slot and it says CFast, it will say caution hot. Yeah, it gets too hot. So they are like, hey, if it heats up, it will drop in speed, because again, the silicon would be like, hey, I'm overheating, so I have to downclock so I do not fry myself. So in those sort of scenarios, the speed, it could go from 3 Gbps to 500. That's not good. You want it to be stable. So for that reason, you need a way to wick the heat away from small points. And this is why they are using so much metal. The metal concentration there is just for that. Wick enough of heat away that it becomes cool. So using normal USB protocol and using normal SSD, they can solve both of the issue. Basically, the throughput requirement and the capacity requirement. You can get that. And thankfully, in last 5 years, I have noticed that a lot of few cameras that directly apply SSD recording, meaning they know this, like specifically smaller camera companies like Panasonic and Blackmagic, they know for a fact if they're like, you have to buy $10,000 worth of cards, people will be like, yeah, I'm not buying it. So what if like, hey, again, if you are using Sony Venus and all that, money is no object. But what if you are using Blackmagic? Money is an object. So they're like, what if we use USB and you can directly store data on SSD? Lot of SSD, just plug, play, done. So instead of getting a recording time in 10 minutes, 20 minutes, you can get 100 minutes, 400 minutes. That's doable. So media and writer, they are done in two parts. The reason for that is this is not supposed to be a complete unit. This is not supposed to where you have USB plug. So it will go into this. This microchip will convert the NVMe protocol to that. The reason why it is separate is that you can swap it, meaning you put a slot, you are adding a slot in your camera at this point in time, and you just like put on, plonk, plonk, plonk. So one is filled up. You do not have to detach the whole thing. You just yeet this puppy, put a new one in. And that's by design. So this allows a much easier data wrangling. Basically, if a camera guy is like working, recording, and his card is full, is like, okay, pulled out, put a blank one in, the full one will go to data wrangling station. Their person will dump that data into two adequate copy, checksum it to make sure everything is fine, then empty it, and then voila, you can keep doing this. So that's the intent of it. That's why it's designed as a swappable rather than this being a complete USB package. So data wrangling, swapping at sort, both are available. And transport, basically the puppy where you're supposed to plug it in, station where you're supposed to connect this puppy in your computer, these are one-time investment. They are expensive, be mindful. This is not SanDisk normal, this is SanDisk professional. They are designed for heavier using cloud. So prices is like high. So transport and stations, these are expensive puppies, but they are one-time investment. You're not supposed to buy them every few months or every few years. You're supposed to buy this as many as you need. For example, if you are consuming 4 terabyte of stick, mag, so to say, 4 terabyte of mag per day, you may buy like, hey, what if we buy 4 or 5 mags just to we can have like, enough spare and buffer. Or you're like, hey, I'm not using that much. So instead of having a lot of sticks, what if I buy one large stick? Or maybe to keep the cost down, you can buy a lot of 2 terabytes. 2 terabytes is the sweet spot in pricing. So you can buy a lot of 2 terabyte ones. That's the whole point. Pro blade logic. Logic is using NVMe itself, using the protocol of USB itself, you're gonna get full capacity that a laptop SSD has. Now, what's the ecosystem? The ecosystem, this is the transport. This is using USB. Now, USB has come a long way, although USB Association started smoking weed and their naming convention makes no sense. I remember the old days, they had USB 1.1, USB 2.0, USB 3.0, and then they were like USB 3.0, Gen 1 multiplied by 1, then Gen 2 multiplied by 1, then it was like, no, Gen 2, 3.2 is like, it went cocaine. So let's simplify. It is using USB 20 Gbps. Be mindful, Apple do not support this. In Apple, you have to go to Thunderbolt to get this sort of speed. They will only support 10 Gbps. Normally available for Windows, you can easily get 20 Gbps. Heck, my computer has this. Pro Blade Transport. Basically, this puppy, you dock it with your camera, and this can directly absorb speed up to 20 Gbps. Now, what does that mean, that 20 Gbps? It means this puppy is fast enough that if you recorded your stuff, like let's say you had a shooting session, you recorded it, you can yeet this puppy out of the camera and directly plug it in your laptop or desktop, directly edit on it. You can directly edit on the NVMe. Why? It is this puppy, it's exactly what is inside your computer. It's fast enough, it's efficient enough, it's competent enough, where it's like, I got this. It has a random read and write. It's like, I got this, fam. It's designed to be read and write again and again and still work for years. This is like, I got this. This is my home environment. You can directly edit videos on this. And I mean 8K raw videos kind of editing. It's like, I got this. That's why that 20 Gbps is such an important thing. And it has a lot of aluminum, meaning if you take this standard, because you are putting aluminum in a case. If the case is not conductive, it will cook. So this transport is also made out of thick aluminum. And again, it also has to cool down the USB converter chip. So it has USB converter chip that is being cooled down. So that's why that block is there. It's cooling the USB chip. So benefit is lot of heat dissipation, meaning not only this can dump heat, this can also dump heat. You will never reach a point of thermal throttling. So SanDisk put some effort into this design work. And what about power? When you are running it on camera, your camera should provide enough power for this. And again, these are energy efficient devices, so it can easily handle it. Now that's just the transport and the cartridge part, or mag. SanDisk Professional Pro Blade Station. This puppy, ludicrously expensive. Don't even ask the price. This is designed with 4 readers, and all of them will work simultaneously. It's not one of those card reader where it's like, hey, I plug one card, the other does not work. No, all four will work. And this is designed for Thunderbolt interface up to 40 Gbps, meaning 4 gigabytes per second. Basically, it's fast enough, meaning you plug one in, it will saturate the full speed. If you plug 4 of them, basically, let's say data wrangling, you're dumping a lot of data, this puppy can still give you 1 gigabytes per second on per drive. Meaning you can, like, let's say somebody gave you a shoot, you plug it in, you have 2 other, it can take data from one and dump it both of them, clone at the same time. So you can do very high throughput. And be mindful, Thunderbolt interface is one of the fastest interface available right now. You can utilize that. It also comes with USB-C 100 watts of power. Yeah, this is an energy intensive device. So you can do that. You will reach full speed, or even the slowest speed you're gonna get when you have all 4 saturated is 1 gigabytes per second. And you see, this is the contactor. The contactor is the basically the reason why they needed to make this system. There are 2 benefits. First benefit is aluminum shielding and all that. Second is this connector. This connector is designed for hot swapping, meaning it will not arc out, nor it will cause an issue. And it's designed like a SD card, so it has a notch. So benefit is you cannot insert it backwards. You will not be able to fry your system. So it's designed to reach 1 Gbps per. Mac systems are asymmetric. You cannot mess it up. And that's the whole point. And you can see, you can use this, basically this transport, as a direct USB-C external media. You do not, and again, you can have this in your computer and just swap this, keep coming out. You can do that. And this is just one unit. They also have made a RAID unit where you have 2 hard drives cloning with each other. So if one hard drive dies, you do not lose your data. That can also digest it. So it's a full ecosystem. Let that be very clear. I'm talking only on 3 things: the mag, the transport, and the docking station. But you can, if this is too expensive, you can still buy only 2 of these, basically one with your camera, one with your computer, and you can still swap mags between them. That can also be done. This is more focused on, again, branding is SanDisk Professional. It's designed for data wranglers, so heavy users. So that's the ecosystem. Surprisingly thorough. Expensive, but thorough. So for whom these puppies are made? Basically, there are 3 camera companies that can support this. Blackmagic, many Blackmagic supported. People are like, shut up, take money, this is good. And again, Samsung T5, T6, T7, these SSDs became very popular because that's how people were capturing on Blackmagic, raw. So Blackmagic is like, I got this. Panasonic, a lot of Panasonic support this, be it Micro Four Thirds or full frame. I think, if I'm not mistaken, G5 Mark II, I keep forgetting the name is so convoluted. It does have SSD recording. So you can directly have this handle. Now this handle is made with collaboration with SanDisk and Condor Blue. That's the name, don't ask me why. So the idea is you just have this handle, you use it a handle, and handle stores the Macs inside it, and direct USB-C connection. So you have Blackmagic, you have Panasonic, and one Nikon body does the support USB SSD recording, meaning if your camera has USB SSD recording, you can try something like this, Condor Blue, or you can try something like this. So these 3 camera companies have enough options for you where it's like, I got this. Direct, plug and play, you do not have to worry about. You basically be adding external slot in your camera. And then you're like, okay, that's good, but what about Canon and Sony users or other cameras? Assuming you want this bad enough, you have one option that most of these camera companies, specifically Sony, they do allow clean HDMI raw, meaning you're getting full raw bandwidth coming out of your HDMI. And these are generally done so bypass the clause that Red Cinema company used to hold. Now Nikon holds that patent, is you cannot do compressed raw in body, patent lock. So they're like, what if we give the clean HDMI output, the other device stores it? That's legally allowed. So you can buy HDMI capture devices that can take the clean HDMI, raw, uncompressed, compress it, convert it into a package that you want, like a ProRes, yes, Apple ProRes, and then you can store it. Now, generally, most of them have their own supported format. Many of them support this, meaning you can directly dump the data from, so your camera, HDMI to recorder will dump the data into your SSD. So that way you can support almost all cameras right now. These 3 companies directly, shut up, take money, go home. And there are some other also cinema cameras. Well, some cinema cameras like new Chinese brands cameras, they have direct SSD support. In those scenarios, shut up, take money. But for other scenario, you have to go through some convoluted route. But if you are utilizing external monitor for your camera, which many people do, you may be like, minor inconvenience, upgrade that part, or maybe it already has it, and then just like voila. So there's a lot of option, even if your camera does not have like direct SSD recording. So that's there. And what can you do after you utilize this? You can do data dumping, meaning this puppy recorded the data on the SSD, you pull the SSD out, you dunk it here, it dumps it as quickly to your server as quickly as possible, or even from here to other clones. So let's say you buy two 4 terabyte variant, you put 2 4 terabytes here, but all the recording that you are working is only 1 terabyte. So you dump 1 terabyte goes into that 4 terabyte. Now 3 terabytes, remove that stick, put another stick, dump it. That can be, and be mindful, same system can be done with the RAID array, where you can have normal mechanical hard drive, and those hard drive can go up to 44 terabytes of capacity. Consequence, they are slower. They will barely exceed 250 megabytes per second. So you have to be a bit patient, but again, that does allow you to have long-term backup. This will be like, active backup, where it's like quick, I need to quick, and then you do make sure that nobody oopses it. Then you will dump the card at the end of the day into the slow writer. It's like, I'm gonna take my sweet time to back up all the data. It can be done. And why go through all this trouble, right? That's the first question. Okay, let's say I'm using one of the C, still have to buy a lot of Macs, still have to buy a reader for it, still have to buy this or whatever have you. You have to invest a lot. The reason is, if you are a heavy user, not a lightweight user, a heavy user, this will give you a high speed and save time. And not to mention capacity also, meaning you cannot just go to a company where it's like CFast Express. Right now, when I'm making this video in 2024 August, you cannot just like, hey, 4 terabyte. Yeah, price would be bonkers, assuming that even comes out. Right now, the highest I've seen is 2 terabyte, and 2 terabyte price is like, ooh, you can buy 8 of that. 20,000 rupees versus 80,000 rupees. Price difference is bonkersly high. And be mindful, fastest CFast will not compete against this. This is like, bro. And yeah, you may say the USB link is the weak link because it's only 20 Gbps. I'm reasonably sure they can upgrade. If this sells enough, they can upgrade this variant to basically Thunderbolt, where it could be like 40 Gbps. Because the interface is there. It's just that they're using low energy parts, because this puppy requires a lot of energy to work at that speed. 100 watts of power delivery is needed. So, but it does make sense for heavy users. There's a lot of demo where people are like, hey, I'm doing quick shoots and all that, and each shoot is taking a lot of terabytes, like 1 terabyte, 2 terabyte. So like, for those people, because again, you cannot buy any other option. There is nothing else that can give you raw digestion without a bankruptcy. So for those people, it's like shut up, take money. For other people who are like, even if you have these camera, I would say normal SSD will be more than good enough. You may not need to invest in this system. Unless you have a rig and you're like, it would be nice. I can see that, but it's only for heavy user. Let that be very clear. This is not targeted for normal people. SanDisk Professional is there for a reason, and that USB-C recording is not present in Sony and Canon. So this was my presentation on Snapdragon. I'm saying SanDisk Pro Blade ecosystem. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.